All right, let's jump right into this explainer and look at a massive paradigm shift in how we handle factory automation messaging. Right now, MonsterMQ is rolling out phase 1 of their relaunch campaign, and they are completely condensing their messaging to cut straight through the industry noise. For the longest time, we've treated message brokers as these simple, kind of dumb pipelines, right? Data goes in one end, pops out the other. But as factory floors get infinitely more complex and everyone wants real-time analytics and AI integration, that basic pipeline model is really starting to crack. So today, we're going to break down exactly how MonsterMQ is repositioning itself to transform that traditional broker into a true industrial MQTT data hub.
So think about standard legacy brokers for a second, systems like Mosquito. They suffer from a fundamental flaw that you could essentially call data amnesia. They're totally transient. Sure, they pass messages through to your active subscribers, but they immediately lose all the contextual history of that data. If a new client hops on, or an external system needs to know the actual state of the factory right this second, it literally has to just sit there and wait for the next publish cycle. And to fix this, engineers end up building these incredibly messy, multi-service architectures around the broker. We're talking separate time series databases, cache layers, custom glue code, all just to keep track of what is happening right now.
But there is a night and day difference between those forgetful legacy architectures and MonsterMQ's approach. By backing the broker with highly robust frameworks, it isn't just routing your data, it's actively storing it. It actually functions as a Redis Store, a NAT server, and a Kafka broker all natively. It's basically taking that whole messy industrial protocol soup and collapsing it down into one unified data store where your MQTT and Redis clients can read and write the exact same state.
Which brings us to the absolute core hook of their new relaunch campaign. They are positioning MonsterMQ as the open-source MQTT broker you can query with SQL. They're standardizing this exact value proposition everywhere, across their GitHub, Docker Hub, and social channels, to instantly grab attention and stand out from the pack. Because it persists data to relational databases, you can literally query your broker directly with standard SQL to see your factory state on the fly. It's a total game changer for reporting and analytics. You don't need to spin up a completely separate data historian just to grab a snapshot of your production line. The broker itself already has the answers, ready on demand.
And to actually deliver on that bold campaign hook, the architecture adapts seamlessly to whatever infrastructure you're running. Doing a massive clustered production deployment, you can rely on PostgreSQL or MongoDB for those really high-throughput workloads, utilizing a high-performance QStore design that's completely optimized for heavy data streams. But if you're just tinkering in development or running a single instance out at the edge, you can just use SQLite. It perfectly scales to fit exactly what you need.
Let's dig into what I think is one of the most powerful features enabled by this database-backed setup, the last value store. This automatically captures and persists the most recent value for every single topic. Think of it like a real-time, instantly queryable digital twin of your entire factory. With this last value store, external dashboards or AI agents never have to wait for a publish cycle. If a system needs to know, say, if the welding robot on line 1 is overheating, or what the exact pressure of a specific valve is at this very second, it just asks. You get an instant factory snapshot without any of that annoying per-message overhead.
So how does this all build from the ground up? Well, it starts right at the edge of your network. MonsterMQ-Edge is this incredibly lightweight 25 megabyte Go binary with zero CGO dependencies. That means it's entirely self-contained and ridiculously easy to deploy on constrained devices, like a standard Raspberry Pi. It sits right next to your machines, collecting and buffering data locally using SQLite. You can even configure it to keep high churn runtime state entirely in memory to protect the flash storage on those tiny devices. From there, it intelligently routes and forwards only the data you actually need up to your central enterprise broker. It's basically the perfect store and forward architecture.
Furthermore, they're tackling one of the absolute biggest headaches in operational technology, bridging legacy systems over to IT. MonsterMQ natively integrates massive Siemens SCADA environments straight into your MQTT flow. It brings modern GraphQL and WebSocket integration to systems that are traditionally very siloed. Instead of wrestling with complex, super fragile gateways, you're streaming active alarms, alerts, and OPC UA quality codes directly into your MQTT topics.
And I really want to emphasize the staggering scale of this integration. 5 million. Standard MQTT usually completely chokes on massive bulk transfers because it just lacks bulk messaging efficiency. But by leveraging a single, continuous SQL query, MonsterMQ was able to handle 5 million WinCC tags running at 40,000 value changes per second on standard commodity hardware. It effortlessly handles those massive data floods without the typical network choking overhead. Now, once you have all this rich, queryable data flowing, MonsterMQ introduces something truly futuristic. They've built a native AI agent framework directly into the broker using LangChain 4j, which is a library that makes it super easy to connect language models into Java apps. You can deploy AI agents using models like Gemini, Claude, OpenAI, or even run your own local models via Llama. And because these agents actually live inside the broker, you don't need any external orchestration. They can directly query that last value store to get up to the millisecond context of your factory. They even support the Model Context Protocol, or MCP, giving you a standardized way to plug in third-party tools to expand exactly what these agents can do. Taking that to the absolute next level, we get agent-to-agent or A2A orchestration. Imagine a sensor detects an anomaly on the floor and publishes an alert. An AI agent subscribed to that topic instantly wakes up, reasons about the alarm using its language model and the context it pulled from the last value store. And then it can immediately delegate complex tasks to specialized sub-agents across the broker. It creates this living hierarchy of cooperating agents, natively communicating over MQTT topics to solve production problems in real time. We have covered a massive leap forward today. We've gone from a standard, forgetful broker to a unified industrial data hub that remembers everything. A system where you can query millions of SCADA tags using standard SQL, drop a lightweight binary at the edge, and unleash intelligent AI agents that talk to each other to manage your production line. So I'll leave you with this final thought. If your current messaging pipeline is still just a dumb pipe, are you ready to finally query your factory? You can see exactly how they're standardizing this whole new message and redefining the industrial data pipeline by heading over to the MonsterMQ GitHub or Docker Hub pages today.